Hello everyone, so welcome back to my channel. In today's video, we are going to solve today's problem of the day of Bitcoin. And in today's problem, it is the second part of the yesterday's problem, which was we were calculating the waviness of numbering range. And the only difference between the part one and part two is the constant, because we can see yesterday the big of n solution was accepted because the constant was too low. It was around 10 raised to the power 5, I guess. So it was being easily accepted by the league. But in today's problem, the constraints are too high because we cannot write if okay, listen, in the worst case situation, the number one can be 1 and the number 2 can be 10 raised to the power 15. So we have to iterate through 1 to 10 raised to the power 15, which means we have to, for calculation of the number of peaks and valleys, we have to travel each digit. At max, we have to travel 15 digits. And how many numbers can be there? There can be 10 raised to the power 15 numbers. So approximately it will be big of 10 raised to the power 15, which is much greater than 10 raised to the power 8, and which will eventually get us time limit achieved. So we cannot write direct solution of big of n for this question. Instead of this, we have to use it's a DP problem, and it is a part of it is a special type of DP that is called as a digit DP. So you must learn about this digit DP and how it is being implemented. So in this video, I am just going to show you the code and what the code is actually doing for this problem. I'm not going to teach you everything from basic of digit DP. You can refer any other lectures. I will just implement the digit DP for this question. And after when you will learn the digit DP, even if you know the template of digit DP, you can easily solve this problem. Basically, what actually we do in digit DP is like finding the prefix sum. So suppose if we are going to find the prefix sum, that is the prefix sum for this array is 10, 1 plus is 10 and 15. And if we want to calculate the sum of between 4 to 2, what we do, we will find the nums of 4 and minus nums of 2 minus 1, and we will subtract the value, that is 10 minus 1, that is 9. And this will give us 4 plus 3 plus 2, that is 7 plus 2, that is 9. So this is how the prefix sums works. Then somewhere the idea of prefix sum is used in this concept of digit DP. Okay, so let me show you the code and how it will work in this program. First of all, we will initialize. Okay, so first of all, you know this DP, how DP, because first of all, understand the recursion of this DP, because after writing the recursive code, we can easily memorize it. So first of all, understand how this recursive solution works. And if you know how digit DP is used to solve, and how we can use the concept of digit DP to solve any this type of problem. So you know this is a very basic template, and just we are going to just see this code. So this code will make all the changes what we are going to do. So first of all, let us take any cases, like I'm just taking 120. So first of all, I will check number from 0 to 120, but not linearly. I will check if the number is 120. So in the first case, what are the numbers we can have? That is 0 and 1. In the second case, if I am choosing 0, then how many numbers can be there? There can be 0, 1, 2, 3, 4, 2, 9. And but if I am choosing 1, what are the maximum number I can find in the second case? It can be only 0, 1, and 2. It cannot be more than 2. So if I am choosing 0 and then I am choosing 0, and then further what I can choose any number from 0 to 9. So you can see that there is a concept that is called as type. In a digit DP, if type means restriction, if type is true or false, type can be a Boolean value. Type is true, it means that we have some restriction, we cannot have the numbers from 0 to n. But if the value is false, we can have the number from 0 to 9. There is no restriction, we can choose any number. As you can see that if our number is the maximum of the number, obviously if our limit is 120, how we can take a number that is greater than in the hundred space, how can we take a number that is 2 or 3? We cannot choose any number that is greater than 1. So it is a concept of digit digit. We cannot choose any number. We can only choose those numbers which maybe which can lie in the range of that particular place. So this was a concept of type in the digit digit. So by this you can see that if the value is false, we can choose any number from 0 to 9. Or if it is 2, we can only choose from 0 to the particular place of that number. That can be a 1 or can be 2, can be 3, whatever the number is. So we can only choose those numbers. That is the concept of type. And what is leave zero? Leave zero Lead zero basically means that if we are choosing a number that is 0001, in this particular question, this 001 will never be a peak or never be a value. But suppose if the number is 10, we will get this number as our peak element. This will cause an error for our solution because we have to ignore this leading zero completely. We have not consider we cannot take into take, take this zero into our consideration because it will lead to a wrong answer for a solution. So what will we do? We will ignore the starting zeros because these zeros will not lead to our answers. And then we will check our number, whether it is 2 or 4. So this is the concept of leave zeros. So basically, you can see that I am using a 6 DP. This is a 6 DP. That is because there are 6 transition states in this DP. The first three are same for every type of problem in DP. That is a position, type, and this one. This is called as a lead zero. So these three states are fixed for every type of DP problem. Now we have to check whether what we have to change or not. Like what are our requirements according to a question. So you can check. Let me clear this screen and let me take any number, any gives number. Let me give it any number that is 1, 2, 4. Okay, 1, 2, let's give it 4 to 4, and this will be 0, 1, 9, and this will be 8. Okay. Now let us examine this problem. Yeah. So first of all, uh, what we are going to do, the same process which we were doing in a linear cell. Now we are going to do in our this digit data. First of all, this code is nothing but a DFS. How we are going to choose our DFS? First of all, I will choose a 0 at the most significant bit. I will choose my 0. Then at MSB minus 1 position, all the values that can be considered for the solution at 0, 1, 2, 3, 4, 9, that can be chosen with the MSB minus 1. And then MSB minus 2, I will check for MSB minus 2. So first of all, we must initialize let us check. We have to consider each element, that is, if we are considering a single element, then for the left and the right, the element we have to consider the left and right element of the second index. You can see in this example, and if I am choosing 2, so I have to know that whether which one left and right, both of them I have to know. So, but we cannot check each digit. So we have to store the digit and pass into our array. So if I am at this position, I have to check this. This is called as the last digit, and this is called as the last second digit. So the condition is here. Then the last digit should be greater than 18, and last digit should be greater than last second digit too. So this is the condition for a print. And if I am saying that if the last digit is smaller than digit, so the last digit should also smaller than last second digit, and it is the condition for value. You can see this condition is nothing but it will check only whether the given number is a peak or a value. If it is peak or value, then we are going to add 1 in our solution. But how we are going to initialize LD and last digit and last second digit? Because first of all, we have we have to insert some values for this question. So what I'm going to do, I'm just starting, I am going to initialize last digit and last second digit with -1. And further in the DHS loop, I will update the solution. I will update the value of ID in last second. And so on, I will start calculating the value of the count. I will update the value. This is the base condition that whenever my index reaches the last of the index, I will return the value of the count. So first of all, it is the match digit. Match digit. If our values, so first of all, I will start with the type. Type means that first of all, I have the restriction because I am studying from the maximum significant bit. So like in every case of the maximum significant bit, it can be a limited value. We cannot choose any infinite value for this position because this position will be fixed from 0 to 9. So any number will act as a maximum digit. So if type is 1, then we are going to just impose the position of that particular number. And if it is not like that, then I will just iterate from 0 to what will be my maximum. If it is 5, then I will iterate from 0 to 5. Because the MSB only 0, 1, 2, 3, 4, 5 values are possible. So we can only add the solution, we can only consider this solution only. If I'm going to take 0, so previously it can be a leading 0. So this leading 0 is just a true or false. It's a leading value. Just check whether we are getting a leading 0 or not. If we are getting a leading 0, we will ignore this 0. And then last thing is check that if lead 0 and second last digits are is not equal to -1, that means that our second last digit and last digit exist. If both the elements can exist, the both values existed. So we will just increase our counters from sorry, and then we will just pass our solution, in the recursive solution, we will just pass our count value. And then eventually we will be storing this into our DB and finally we will return our solution. So, as you can see that I am, first of all, I am just talking about the prefix sum. And like that, this can be used. First of all, I have to calculate the number 2 and then number 1 -1. Then I will have to return my 1. So this is the solution can that can only be accepted because this solution works using BP and it can be solved around 720 or 800 iteration. This is around a big of one solution. As you can see, I am going to submit the solution and hence you can see that it is being accepted only.